Okay, so good morning, everyone. Shall we get started? Who is from the support team?
Yes, sir, I'm there.
Okay, I think I cannot share the screen. Yeah, I can share the
I
screen now.
made you the host, sir.
Yeah. Now I can share. Fine. Okay, cool. So, okay. So, good morning, everyone. Hope all of you are doing well. Okay. So, I believe all students are still joining. Okay. Fine. So, hope I am audible and visible clearly. Okay. So, uh, myself, Anirban Das. So, I'm also a working professional working in IT company only. Okay. So today I'm going to go with the revision class of recursion. So it's a revision class. So I think all of you already aware about the basic things of recursion. Okay. And you may already have, is there any echo? Uh, okay, fine. Then Kunal, please check your audio. I think no one else getting it. So Kunal, please check your audio. I believe issue from your end only. Okay. So today we are going to do a revision on recursion. So as I told you, have already learned about recursion. Still, we'll go from the very scratch. So mainly, so we'll mostly focus on the question and confusion you guys are having, and we'll be trying to solve it. So one practice will follow here. So I'll go ahead with the very basic to mid and advanced level concept one by one as per the active lesson plan. And anytime you are having any question, okay, you can actually write down on the chat. Okay, I'll see, and whenever it's possible, I will answer your query. Okay, and if you are having any breaking thing, like you don't even understand and it is very critical for you, you can probably raise your hand. I'll check that out also. Okay, is there any option to raise hand also? Okay, so raise your hand or post your questions in this chat box. Okay, cool. Let's proceed then. So we'll go with the lesson plan first. What is today's agenda? Okay, let me share my screen. Okay, so today we are going to cover these things. So first of all, what is recursion? We'll do one factorial using recursion. I think if you have been doing recursion, you know that the first base problem we'll do using recursion, because it is very easy to explain and you can understand very easily. Then we'll go little mid-level. That's a Fibonacci series. That's a multi-call recursion kind of thing. I like to tell that. Okay. Then we'll explain how the JavaScript call stack work, because recursion is basically if you know call stack, you can actually understand and represent the recursion very easily. Okay. Then we'll talk about why do you need an recursion. Okay. Then the disadvantages of Fibonacci series. Fibonacci, what is the disadvantages of those? Then we'll go with some problem solving on recursion. That is the most important area. The recursion, if you are understanding the theories and understanding from any lecturer or you are reading somewhere else, it's things little critical. Okay. I've seen what happens. Even though I understand recursion properly, I can explain it to someone, but when some problem is in front of me, it is very critical for me to plot that problem into a recursion. So to overcome this kind of thing, what we need to do, we need to do more problem solving in recursion. We need to know properly uh, how do we implement recursion to solve any problem. Okay, because what is our tendency? If I see any problem, I am giving the statement as I already assuming you know basic of recursion, and some of them also relate with me. Suppose I have been given a problem. The first thing I'll think before even going to the recursion, I try to solve this problem using a loop. Okay, because that is what I or we actually more comfortable with. Okay, so but if you do it with recursion, the problem will be more smarter and there are some advantages. But we need to know how to plot that program into a loop, into a recursion from a loop. Okay, so this today's lecture, that's why we mostly focused on this problem solving one thing, because other things are already more or less understood. Okay, and we'll see some applications of recursion. Okay, cool. So let's start. What is recursion? Okay, so I'll go with the programming concept first. See, if you see in any programming language, what is happening? How can I see the chats? Yes. Okay. If you go to the programming language and if I'm telling you what is recursion, all of you know recursion is calling the same function from this function. Suppose I have a fun function, and from the fun function, I'm calling the fun again. So let me share my full screen. Okay, hold on. Okay, now I think you can see the screen. We'll go with the JS fiddle. Okay, so all of you can see my JS fiddle window, right? Okay, hold on. Where is the chat window? Yeah, cool. Yes, I can see the chat also here. Okay, so suppose I have a fun function. It's just a pseudo code I'm writing here, function fun. Okay, and from there I am return, when I return, I'll also return fun. Okay, so this is a kind of what do you call, basic recursion. I can tell that you are calling function from the func. Okay, so fun function is getting called and fun function internally calling again the same function. Okay, so recursion is also, that's why it's called a self calling. Okay, I'm calling myself only from mine. Okay, so that's the programming way of understanding it. But now what is recursion? So recursion is also something called a repetitive what do you call, repetitive actions. So to explain that, let us form a very lame story. Okay, it's not a real life story, it's kind of a lame story I'm going to tell you. So this will actually give you a very base idea of a recursion. Okay, suppose one night one child is not able to sleep, so he asked his mom to tell her a story. So mom started telling a story that there was a frog who was not able to sleep. So in this story also, the mom is actually explaining the sleeping problem of the frog. Now what is happening in the story? In the story, frog is not able to sleep. So the frog's mother also actually explaining or telling him another story, the story of a bear who is also not able to sleep. Okay, and in frog's mother's story, the bear who is having a bear, now bear's mother also telling bear a story that, okay, you someone there is a rabbit who are not able to story, not able to sleep, and their mother is telling him a story. Now by listening the story, rabbit went to sleep. Okay, by seeing the process that how rabbit went to sleep, the bear also went to sleep. Okay, by actually listening or the process, knowing the process of how bear has been sleeping, that frog feels comfortable and he also goes to sleep. And end of the day, by listening how frog is having were able to sleep, the child's mother who started this entire loop, also the child got asleep. Okay, got it? So this is a real life kind of an analogy or some of the process we follow in the recursion. In later point of time, when I go in depth in the recursion, then you will also understand what is actually recursion, how this story is going to relate to our programming language. So remember how we actually solve the story. Okay, we'll going when I go and explain you the first recursion, I'll explain you this story and try to map that also. Okay, in real life also many cases it happens, we don't actually assume or we don't actually think. Okay, but yes, it happens many times. It happens many times. Some actions are actually repetitive and some actions are actually related to another action, and these actions are not even completed until that repetitive or dependent actions are completed. Okay, so in real life also many times we go ahead and use the recursion. Okay, cool. Now let's just go a little back. Okay, I'm explaining this thing one mathematical theory or mathematical process, so that will also help you to form a recursion. So that process is called mathematical induction. Okay, so it's a discrete mathematics subject. Okay, so that's called a mathematical induction, or mi also you can tell. Okay, so what is a mi? Okay, so in mi we actually prove something. Okay, in mi there are some basic step. Okay, in basic step we prove that basic step is correct. Then there will be an inductive stage. Inductive stage, what we do, we assume that is one thing, one theory is correct. And in the proof method or proof last stage, by using my inductive stage, what I do, I prove my exact theory. Let's just give you an example. Okay, so suppose I'm just give you a small example. Suppose let's see if in f1. Okay, let's suppose go for something called f1. F1 is true. Okay, f1 is true. Now what I will assume, if n is also true, if n is equal to true. So this is my inductive or assumption state. I'll assume. Okay, when I go to a real life program, I will also show you how it will work. So if n is called a basic step, if f1 is called a basic step, which I can calculate in my mind also. Okay, and if I give you an example, suppose I am thinking about the factorial program. Do you know what is 1 factorial? Do you know what is 1 factorial? 1 factorial is always 1. Always 1. Yes, good, you are participating, that's great. In fact, 1 factorial is always 1. So I'll just assume some problem. Suppose fn is actually n factorial. Okay, and I assume that is true. Okay, I'll go ahead and write the problem later. Let me just clear the screen. Okay, suppose fn is n factorial, that I have assumed, and I'll prove if n plus 1 is equal to n plus 1 factorial. Okay, so that is my way of solving something via mathematical induction. Okay, so now I'm not doing a mathematical logic. I'm not going to give a math paper. So we'll not concentrate on how do I prove n plus 1 is equal to n plus 1 factorial. Okay, that we don't need to worry about. We don't need to go in deep. Okay, we need to think about here, we need to think about the assumption state. So this step is very crucial when you are building a recursion logic. Okay, when I go to the factorial problem, that is my next step. I will tell you how do we do it. Okay, so everyone, any question until now? I'll just give you a 2-minute of gap. Okay, just to formulate any question you have or not. Okay. I believe all are fine. Induction in a recursion. Okay, fine. Okay. So Deepak, your question I will answer later. When it is bad, and when it is good. Every everything we learn in programming has some spaces to be applied. Okay, like I have learned recursion. Definitely I will not go and everywhere I'll just write recursion. Whenever I see a loop, I'll just go with the recursion. That's also bad. Okay, so I'll give you in this class, it's only hello guys, can everyone go on mute? Yeah, in this class we'll only talk about the recursion. I'll give you one overview idea that why recursion every time we should not use recursion. Okay, that's a one overview I'll give you. And basically what happens when I use recursion in every places. For that you need to actually go a little deeper, that I think I cannot cover in the same class. Okay, but yes, I'll give you the base idea, and there are some difference all there also. Okay. So and another question, explain induction in recursion. Yeah, I'm going to that step only. When I explain you about the recursive or factorial, you'll get to know how mathematical induction is actually used in the to build a recursive knowledge, also recursive example also. Okay, so so there are some analogy we'll be using, so let us not confused on that. Okay, so there are one step I told here, it's called a I told that it's an inductive stage. Okay, so this step I am thinking about the inductive stage. Okay, sometimes we call it the assumption stage also. We are not going with the mathematical, we are actually doing something that easy for understanding for ourselves. So it's our assumption state, because we actually in this step we actually assume that whether this will be true. Okay, so let's just remove this and I will go with the recursive problem. Okay, let's go with the recursion with factorial. Now all of us know actually what is a factorial. Still I'm just writing something like there is something called 4 factorial symbol. What is the meaning of 4 factorial? Is 4 into 3 into 2 into 1. Okay, that is the things of your factorial. Okay, now how do I balance it? So first thing is my base case. Okay, so base case means 1. So suppose I am writing here f1. F1 is equal to 1 factorial, correct? So in base case, I can assume f1 is always 1. It's not an assumption, it's a true thing. In the base case, it's always happens. So you know that 1 factorial is always 1. So f of 1 will always be 1, correct? Now I'll go with the inductive stage. Okay. Now in inductive stage, what I can assume, there are f4 into 3 into 2 into 1. Okay, so what is happening here? In every, if I'm going with 4 factorial, so 4 into 3 into 2 into 1. Okay, what is happening? This is a into relation. That means if I'm thinking 4 as n, now assume 4 as n. Okay, until this is n minus 1 factorial. See, until this it's n minus 1 factorial, correct? 4 into 3 into 2 into 1, that means 4. If 4 is n, then 3 into 2 into 1 is basically a n factorial, or sorry, n minus 1 factorial minus 4 minus 3 factorial. If you think about 3 into 2 into 1, it's 3 factorial. So n minus 1 factorial. So if I consider n factorial here, so what will be? It will be 4 equals to n, then it is n. Then what it will be? Into what it will be here? N minus 1 factorial. Got it? So n factorial is equal to n into 1 minus 1 factorial. Now, as we already know what is a recursion, what is happening in recursion, so we are actually able to do it in this same way. Okay. We are able to do it in a very easiest way. But in case if you writing if n minus 1, the what is my inductive stage? N minus 1. Okay, I am assuming n minus if n minus 1 is equal to n minus 1 factorial. That is a true state. This is my inductive stage where I assume n minus 1 is equal to true. I'm assuming this is true. Okay. Now, by my assumption, I know that in my if n is equal to n minus 1, now n means n factorial into this fn. So in this case, I'm actually f into this. This is I'm actually assuming n into fn. N factorial means m into fn. Now fn stand for n minus 1 factorial. So in my next line, so what I can do, fn is equal to n into n minus 1 factorial. Got it? Clear? Somebody asked about the inductive stage. Okay, so Nilanjan, is it clear what is induction in recursion? Nilanjan, are you there? Line number 3. Line number 3, it will be n factorial n into fn. Line number 3, n factorial m into f. Sorry. It will be n minus 1. Yeah, thanks. So if n minus 1 only, not n minus 1 factorial. If n minus 1 is equal to n minus 1 factorial. Got it? Yeah, I best did a mistake. So it's if n minus 1, which is equal to, I have already assumed, this is my assumption, that if n minus 1 is equal to n minus 1 factorial. So in the line number 3, what I have done, if n minus 1 factorial. Got it? Cool. Nayan, Hariharan, you are asking about 2 to 4. Can we explain 2 to 4? So in line number 2, actually we have assumed, I've told you this is the assumption state or this is a inductive stage. Okay, that means if n minus 1 is equal to n minus 1, it is true, I have assumed. Okay, now in line number 3, what is there? N factorial into n minus 1. Okay, that is the rules of factorial. Okay, n into n minus 1. Okay, so that's what I have written. So n factorial into n into if n minus 1 factorial. That is the rule here. You know all that rule of factorial. Okay, and in the fourth stage, if n is equal to n factorial and if n minus 1, which is true, that actually n minus 1 factorial. So n into n minus 1 factorial. Any other question? Any question? Nayan, Hariharan. Okay, got it. Nayan. Cool. So cool. So that's how this is all about now theory. Okay. Now what I'm going to do, I'm going to actually implement the same thing in my programming. And how difficult it is? It is very easy. Once you have explained all the thing, once you have done this kind of thing with any mathematical logic or any logic, then programming is the same thing what we are going to do it here. Let me just show you. So as I told you, the same thing, let's just run a function. So I think you are clear. So let's just do a function factorial, and it will take n. And what was my stage? N into n minus 1. I'll go the same thing, return, okay, n into n minus 1, and that is a factorial. Clear? So this is my factorial function. So that is calculating n factorial. And what is my inductive stage over there? N into n minus 1 factorial. So n into n minus 1 factorial. See, it is actually similar to like this, n into n minus 1 factorial. But I know that in my programming factorial stand for factorial. I have written so n into n minus 1 factorial. Okay. Now programming is not ended here. There is one thing still we need to do. Okay. But before that, have you understood the conversion between this and this? Okay. So here what I'll do, I'll call the factorial function. Okay. Got it? No, I'll go ahead with the factorial function. Now, what is happening here? So if I leave this function like this, what will happen? It will keep on running. I never told this function to stop. Okay. Even though mathematically thinking, it's theoretically it is correct only, but if you think properly, this function will keep on running. Okay. So we'll do a dry run in later point. Okay. But before that, there is something that I can see. There is no stopping condition. Yes, that's a cool assumption. So there are no stopping condition. So this program will keep on running. So can anyone want to participate? What can be the stopping condition here? Yes, that's a good thing. For n is equal to 1, we need to put some condition. Okay. So that's the stopping condition for us. So what we'll do here, if n equals to 1, okay, and we need to condition, we need to put a return 1. Now the question is, why return 1? Why return 1? Yes, that is my base condition. I told you in induction, first of all, we detect the base condition. So base condition will be useful for your stopping condition also. Okay, so base condition, we have assumed that 1 factorial is equal to 1. So that's what we are going to here do it here. Yeah, I'll go ahead with this one by one. We'll write Shibam. Okay, so first condition is there. So we'll detect what problem will return. So first condition is n factorial is equal to 1. So return 1. Cool. So this is my first thing. Okay. So this is what, like, let's just check it out. Let's do with the 4 factorial. Okay. I believe you can see my console also. Okay. I need to do factorial 4 and console.log factorial 4. Okay. Let's clear the console and run it. Okay, there is some error, untuck syntax error, token. Okay, I have not removed all the things from the top. So let's just comment it out. We don't need these things. Okay, so Dipanksh, your question is maximum stack flow is related to infinite recursion call, because I see whenever I code, okay, it's a control slash. Anyone want to know? There's a control slash. Select and control slash. All things will be commented. Okay, so Dipanshu, I'll go this topic in the later point. Okay, how we what is the infinite stack and what happens if there is a stack, what that if you are not giving a stopping condition, what will happen there. Okay, fine. Let's just run it. See, it's calling 24. So what is the 4 factorial? 3 20 to 12 into 2 24. That is correct only. Okay, so factorial is actually working fine. Okay, now what will happen if I go with the -4? That's what the confusion here. See what is happening here. Maximum call stack exceeded. Uh, yes, factorial of negative number doesn't exist. Okay, that's our mathematical thing. Yeah, this error we will face a lot. That's why I give this -4. If you go with the -4, this error will occur, and I'll tell you what is this error. What is that? If we add, if n is equal to return 0, why should I return 0? There are no 0 factorial, right? Factorial start from 1 only. Positive number is having factorial. Yeah, that. So whatever you are actually suggesting, Shivam, here is to make our program. It's called a what do you call logical error handler. Okay, we know that we should not allow less than 0. So I can put a condition here that will actually avoid my error. So any range error, any reference error, we should not expose to user. If user see this kind of error, user will understand what language you are using, or what might be my what is the code vulnerability we are having. So to avoid this kind of mistake, we can do many things to avoid. Like I can also do something like with factorial will never run if you give a negative number. Okay, those are some programming tricks and hacks. Maybe I'll discuss lastly. Okay, let's go ahead with many program, then we can discuss lastly. Okay, now maximum call stack size exit, I'll explain. That's why I given that one. We'll explain after some time. Okay, cool. And yes, if your recursion is not properly implemented and your base condition is not proper, you will always get a maximum call stack exceeded, because all programming is having, every system is having a limitation. Okay, cool. Let's move to the next topic. So next topic, we are going to cover a very important thing that is called call stack. Okay, which is a very key concept of JavaScript. Okay, not only JavaScript, if you go for any language, stack is very important. So let's just talk about the stack. Okay, can I remove all the things? Okay, so let's talk about the call stack. So what is a call stack? So before knowing what is a call stack, I'll just go and give you a very basic understanding about the stack. I think all of you know about the stack, but still we'll go with that. So stack is actually a data structure. Okay, and what is the data structure? Basically, data structure in a layman language, nothing but how we store our data, in what algorithm we use to store our data. Okay, even though if you are in your home, if you have some things, like if you have a bottle, suppose you have some books or many things. Can everyone please go on mute? You may have books in your home, you may have some bottles, you may have some bucket, you may have a number of things in your home, right? So how do you arrange or store these things so that you can conveniently access those things? Can you please go on mute? Everyone please go on mute. How they near some, please go on mute. Yes, fine. So how do you arrange your things in your room so that you conveniently access? Okay, so that's how you manage your room. In a memory also, something like that, I have a very good memory structure. Okay, memory means nothing but a tabular structure in our system. Okay, so I have data. Now I have a vast memory location, and how do I store my data? Okay, so that's depends on the data structure. So in a very basic thing, data structure, there are two kind of data structure. That is, one called linear, one is non-linear. Stacks fall under the linear data structure. That means where I keep my data one after another. Okay, that's a linear data structure. Okay, so now let's talk about what is a stack. Okay, so if you're good and if you have a knowledge on English, you know stack is mean this stacking somewhere. So suppose think about something called, you have CDs, right? In nowadays we are using pen drive, memory chips. CDs are actually going to be deprecated. So still, if we are all at least some point we are not that much younger, so at least some point of time you have known what is a CD rack. So this kind of CD rack you used to have, right? So on that you need to store the CDs, whether it's your game CDs, whether it's your movie CDs, or some song CDs. So you need to keep the CDs, all things. Yes, you are keeping one after another. Okay. So what is this property of this CD? This is also called a LIFO. What is LIFO now? LIFO mean last in, first out. That's a LIFO. That means whoever is actually, see, correct, Nirjan, whoever is coming last, they will be out first. That means if you think about a CD rack, so that's suppose you have some movie CD here, and you have some song CD of some very good English song CD, and you want to actually listen the songs. So as it is last, you need to pick it up fast only. Okay. Now you have done some game CD at the last. Okay. You want to hide it from everyone, otherwise parents will create more issue. We are playing games, so game CD at the last, so nobody can actually pick up the game CD fast. Everyone, if you want to have to access the game CD, you want to pick up each and everything one by one, then only you can go for the game CD. So that's called a last in first out data structure, and that is a stack. Okay. So now in programming also, if you think about a JavaScript call stack, that is also kind of a these kind of things only. Okay. So these kind of things only happen in JavaScript call stack also. Like what? If you think about this, then JavaScript also maintain this kind of a stack where he actually put program one after another. Okay. Let's just do some very small program now. Okay. Let's just think about, don't for a moment just come out of recursion. We'll do a very small program. Suppose let's go with the function, and I have function here. I have console log, and I have this function. So suppose let's write something in console.log also, so it will be interesting. Suppose hello. Okay, sorry about my handwriting, because this I rarely use this pen paper pen thing. Okay, so this function I have created function, suppose function if. Okay, so what I'm going to do, whenever I execute, whenever JavaScript you need to execute these things, what he will do first, he will just put this, entire thing into this call stack. Okay, one fun function will be created. So the function name is fun. This fun function will be created, then JavaScript will execute this. Okay, this is a very basic thing. Okay, now let's move to very one complicated thing. Okay, little complicated, not that much, little complicated. My voice is breaking, everyone. Is it breaking still? Okay, okay, fine. Maybe some network issue for some time. Okay, so let's just go with it. Function fun one. Okay, here what I'll do, I'll call a function 2, fun 2. Okay, that is another function. Okay, here. Okay, now here I have defined the fun 2. Okay, fun 2 I have defined here. Suppose console.log something is there, and it is also defined function fun2. So there are two functions. Now when JavaScript started executing, what he got first, I'm actually calling what I'm actually calling here, I need to call the function, right? Otherwise it will do nothing. So suppose I have called fun1. Okay, what JavaScript will do, JavaScript got a fun1 call. So yes, JavaScript will pull all the fun1 code here. Okay, so let's go with the fun1 he called here. Okay, it's a first call. Now inside fun1 he got fun2. Okay, now he will take the fun2 and put it over the fun1, sorry, fun2. Now fun2 is the next part. Got it? Now what is happening? These are the two functions pushed into the call stack. Now when I'm actually executing, I already told it's a last in first out. That means fun2 will get executed first, then we'll go with the fun1. Okay, so that's how JavaScript call stack work. So fun1 will be this console.log, something I have written in the fun2, right? That will get printed first. After that, if I have done something below the fun2, that will get printed. Okay, so that's how JavaScript call stack is working. It's a stack manner, and it is put one after another, one after another. So that's how a call stack work. Is it clear, everyone? Then I will go with the recursive first call stack. Clear. Another thing, I'll be using this analogy, and sometime you will get this analogy in your what do you call in your interviews also. Pushing something, this process is common in JavaScript. Yes, this is common. So in every language, whoever is using stack data structure, even though in JavaScript you will keep your own data in a stack manner, the property of stack will remain same. Okay, whether it's a JavaScript call stack where or you have created a new stack in your JavaScript to keep your integer values. But if whenever you are creating a stack, property of stack remains same. That's why we call it a stack. Okay, now another thing I am going to tell some analogy. Pushing something into a stack, it's called a push, and and just out, like picking something into or moving something into a stack, it's called a pop. Okay, so here this one, you can call a push, and this one you can call a pop. Okay, so in later point of time I may use this language, so it's also useful for knowing that push and pop thing. Okay, and there is one thing I need to mention. It's not related to this topic, but I saw some of them are actually getting confused on that. There is something called pick also. Okay, what is a pick and what is a pop? Pop means you are actually removing the entire thing from here. Okay, pick means it is there, but you are taking a copy. Okay, it's not related, but since I am explaining you a stack, so keep remember, later point of view you might know this. Okay, fine. Now let's go with my recursion. Now what happens in case of recursion? We'll take this factorial program only. Okay, we'll take this factorial program only and try to explain in a call stack. Okay, cool. Now let's just let me draw a stack for factorial. We already know the factorial problem, how does it work, and we'll be explaining this using a stack. Hold on, something got clicked. What happened? Let's just go ahead and write down another stack. Let's have a long stack here. Okay, so that I can play around with. Now, as per my previous understanding, I'll be writing the factor. Let's call it fact. Okay, fact 5. I'm going with fact 5. Okay, and all of you already know that what I'm going to write inside the fact function. So let's just write that one also. So it's a definition fact and in. Okay, what is happening here? Return what is going to be here, n into n minus 1, and that also call as a fact n minus 1. Okay, and I suppose I have a base condition n equals to 1, then I'll go ahead with 1, return 1, sorry, return 1. Okay, as I think you have understood what I have written here, that's why I'm just reading it out. I know my handwriting. Okay, so let's just do a dry run here. Okay, what is happening here? Fact 5. I'm going to call it using a fact 5. Okay, so now what will happen? This fact 5 will pushed into the call stack as JavaScript always pushed fact 5. Correct? Now fact 5 internally calling what? Fact 5 into fact, here return 5 into, so it is actually doing 5 into, then what is doing? N minus 1, that means 5 minus 1. It is calling fact 4. Correct? Everyone, am I audible and clear? Okay. Now, as JavaScript go in a stack manner, fact 4 it is going to push here. So it will be fact 4. Correct? Now, fact 4 going to return 4 into fact something. So that is actually, it's not going to queue. It will go one by one. You don't call it a queue for now. Queue also have some other property. That's why you don't call it queue. Yes, yes. Whatever you told, that's fine. Let's just or plot it in Shivam. That's fine only. Let's just plot it in one by one. So it's fact 3. Yes, top one is go with fact 2. Okay, and last one will go with fact 1. Okay, so after fact 1 it will stop because we have a breaking condition. What? Fact, if that is a fact 1, then it will only return 1. So this one got executed and give a 1. This one give the 1 to fact 2, then it will be 2 into 1. So this part will go to fact 3 because fact 3 will then execute it 3 into 2 into 1. Let's just write it here. First return 1. Okay, then what it return? 2 into 1. Okay, this 2 into 1 is passed to the next. It will be 3 into 2 into 1. Okay, this one will return to the last. It's 4 into 3 into 2 into 1. Okay, and if I'm going the last fact 5, it started with 5 into 4 into 3 into 2 into 1. Okay, so that is my result of factorial. So fact 5 will return this, and this is basically a 5 factorial. Okay, clear how it is actually going to stack and we are popping it from stack? Is it clear, everyone? Clear. Cool. Okay, any more question you guys are having until now? Okay, now we'll go to something that call a stack overflow. Okay, it's a very common term, or maximum stack. Okay, the limit of stack depends on your system basically. Okay, the limit of stack depends on your system. It may be good in your system, may be different in another system. Yeah, you can tell RAM. Okay, let's just now do it. One small programming. It's a very small programming I'm going to do. Let's just from now only. Fun. Okay, function fun. Okay, what it is going to return? Return code forces that some see memory limit exit is always happens when your memory you are actually going out of memory. Okay, so no matter what you are trying, you may go out of memory if your code is having a bug. Okay, and now it's a very what do you call debatable statement that always memory limits on your code. So there are many other way where the memory limit exceed is happening. It can happen. It can happen. The memory limit exceed can happen in, suppose you have a 16 GB RAM and you are not even allowing, now you are using 16 GB RAM, still memory limit exceed will happen. There are many other way. Okay, if I have a time, I'll tell you some of the scenario. For now, we'll just take the stack limit exit, what is the programming stack is exceeding. Okay, let's just return this, return fun function from here. Okay, and return, just go, I'll just check how much my system's power. N is equal to 1. What I do here, console.log plus n. I'll just keep on increasing my value of n. Okay, now here I'm going to call fun function. I hope my system will not hang. Okay, I hope I have a good system, so let's just pray for best. Let's see what happens. See, you can see my console, right? It is keep on increasing. Okay, that means it is keep on calling the stack, like it is not, it's never ending, it's a never ending thing. Okay, now this way I can check my system. Okay, my system is having a very big power, so I think it will take a hell lot of time to exceed. Okay, but it will go on. It will go on. So I didn't run a loop. I just ran a 2 lines of code, and I have a, yeah, I have a 16 GB RAM here. It's a good system. So if you guys are working with Android Studio or Android system, so you might have a very good system. Okay, so for me it's going up and up. I know it will take a lot of time. If you are actually using a Pentium 1 system and it is having a 2 GB RAM or something, it might have exceeded somewhere sometime else. Okay, so but for me it will take a much time to exceed. Okay, so but understanding is that, so until my memory is okay, my memory is telling okay, go ahead, and whatever I have power, that many time it will keep on running. When my memory will tell okay, I don't have many power here, it will get exceeded. Okay, so that's the first thing we know. So it will not actually stop now. I need to run another thing, then it will stop. Let's just run. And let's just show you something here. Okay, let's just go to my Windows Task Manager. What is happening in this case? See, if you can see the Task Manager, and see the memory for micro. I am running it in the Microsoft Edge. So see the memory of Microsoft Edge. See, every time it is increasing, right? Can you see that one? Microsoft, every time it is getting increasing. See, it will keep on increasing. It is nowhere stopping. It will keep on increasing. This 78, 86. So the moment it reached the threshold, it will tell me, boss, I am done. You buy another system. Okay. Now let's just go ahead and stop this thing. I believe I need to refresh. It is hanged already. See, now execution got stopped. Discard. Okay, now let's see my memory. See, it came down. It was there 500 something, now it keep down. Okay, so got it. See, it is now 185. It will keep down. It will just take how much memory I just need to run a Microsoft Edge. Otherwise it will go down. The moment I started running, each and every minute is going. Okay, got it. So this is how a memory stack works. This is how bad recursion can ruin your system. Okay, cool. Now let's just do one thing. We have crossed 1 hour, so let's just take a 4-5 minute of break. We'll start by 9 p.m. again. Okay, it's 8:55. Cool. Hey, hello everyone. So I can see someone is taking the dinner break. No, no, it's not a dinner break. You just go ahead and take 5 minute break. That's what I told. So it's 8:59. Let's just start. So everyone is there. Just give me a heads up so that we can start. Cool. Now I'm going to explain some of the part or some of the disadvantages of recursion, and in real life where we should use recursion and where we should not use recursion. Okay. So first of all, let me just go to deep dive into real life programming. So do you guys think in when I'm yeah, thanks. I'll go with the later part also. If I have some time, I'll give my introduction also. Okay. So let's go to your real life now. Okay. So everyone, I think it's a common for everyone. You know that if I am going around into real life programming, if I'm building a website, if I'm building a web application or a software, I'm not going to write a code to calculate recursive, right? Calculate factorial, right? It's a very lame thing. It's already available in market. Okay. There are pretty much many good systems that can do. So I'm not going to write, like, there are no problem I'll face in my real world. There I need to write factorial programming. So that's why it will don't memorize any programming because you will not have it. So what I do basically, okay, what we do basically when we're actually developing a software, we do many things. Okay, but if you think about code now, again I'm going to give you a debatable sentence. Okay, but it's just for understanding. If you think about a code, 80% software nowadays we develop, we manipulate data or work with data. Okay, we get data from somewhere else, do something with those data and push it to somewhere else or give it to someone else. That's why in your real world, you will know right now, data is the most important thing. So what happens if I use recursion when I'm having a large data? Okay, now what I show here that I am just printing an infinite loop of some number, one small integer. Okay, and that what was happening in each and every second, it is actually eating 2 MB 3 MB memories. Okay, now think about that. Your programming is handling with some database object. Okay, that is having suppose 3 MB data itself. Now, if you are using recursion to calculate or recursion to do anything, so and your recursion is actually 5 loop or 10 loop long, so your entire function will take 5 into 10, 50 MB of resources. Okay, and it's a very small thing I told. You might be handling with 100 MB data, 100 into 10, 500 MB, like half a GB data to run one function. Your software will be never efficient. And when you are launching this software into web, you are not the only one who is using. There will be thousands of using are attempt to use the software at the same time. Your system will definitely break. Even though you have a very good code, you have shown to a client that okay, see, the system is running. Whenever 1,000 user is coming, the system will break. Definitely it will break. Okay, that's why we think about the memory very crucial. Okay, and memory is very expensive. Nowadays, I am in my for local system, I can buy 16 GB RAM. That is enough for me. If think about a server, they have more resources. Okay, they need to buy a high performance server. They are very costly memory. Okay, so memory is very crucial. That's why whenever I am using a recursion, I need to be very clear that how much memory it is going to consume. If I am doing a recursion and I'm handling large set of data and it is eating a lot of memory, I should avoid doing recursion. I'll do it for loop. Okay, it will increase my time complexity. Okay, that means it may require more time to give me the answer, but it's also okay. Okay, because I don't worry about my memory exemption. Maybe my system is a little bit slower as I'm handling with large data, but it will not going to fail. Clear? What is the real life understanding of recursion? We understand. Fine. If it is clear, we'll go to the next segment. That is the Fibonacci series. Okay. Can anyone tell me what is a Fibonacci series? Let me share the screen again. Guys, am I audible, right? Yes. So what is Fibonacci series basically? Let's just understand that one. My dashboard. Okay. Let's just understand. Let me clear it. Okay. What is the Fibonacci series? Basically, let me write it down. Yes, current and previous number. We have learned it many times. It's 0, 1, 1, 2, 3, 2, 3 are 5, and 3, 5 is basically going to be 8. So what is this Fibonacci series? So 0 and 1, if you think about 1 and 1, 0 and 1, if you do a summation, it will be 1. 1 and 1, it will be 2. 1 and 2, it will be 3. 2 and 3, it will be 2. Basically, the number I am taking, it is a summation of its previous 2 digits. Okay. Yes. Okay. So the base logic is the number in any number is actually a summation of its previous 2 digits. That is basically your Fibonacci series. Okay. So I'm going to do the same thing with Fibonacci series. Okay. What is a Fibonacci series and how do we do it using a recursion? Okay. Let's just write Fibonacci series here: 1, 1, 2, 3, 5, 8. Okay. What is my function will be there? I'll just write the function definition. I'll write later. Fibonacci. What will be there? Fibonacci 5. That means I need to print up to 5. 1, 2, 3, 4, 5. Up to this, I need to print. Okay. So we'll do the same analysis what we have done before. Okay. So first analysis I need to do is a base analysis. Okay. What is the base analysis? So if you think about the base, f0 is always 0 and f1 is always 1. Okay. No matter what you do, your first digit f0 is always 0. That means f of 0, that means first digit is always 0. If I sorry, f1, if I start with 0, f1 is always 0. That means if I try to tell Fibonacci 1, I can easily write Fibonacci series of 1 digit is always going to be 1. Okay. Or if I go with 0, 1, 2, 1 is 0. And if I think about Fibonacci of 2, you know it is always be 1. Always be 1. Correct? So this is my what? This is my base case. Okay. Let's go to the Fibonacci series here. Let's go, let's go, let's go. So this is my f of 0 answer is 0 and f of 1 answer is 1. So they have so we can also think about from f of 0 also. I'm thinking about f of 1. Let's just make it 0 for now and it is 1. So that remains same. F of 0 is 0, f of 1 is 1. It is easy for understanding. By in programming always start from 0. So it's 0th position, 1 position, 2 position, 3 position. Okay. So now inductive stage. What is my inductive stage here? Can anyone want to try? Inductive stage, or I can tell assumption stage. What is assumption stage? What can be the assumption stage here? Anyone want to try? You can write in, just let's give a 2 minute, think about that, and then you can write it in the chat. What is my assumption state? This is the final step. Okay, this is the final step. Okay, I need to assume it. What you have written, that's correct. But I need to assume something before I move to this stage. Okay. Yeah, we have done Fibonacci series, and in my mind, I know we can do it. Okay. Um, kind of correct, Harinaran, but I will tell you. You just need to tell something like this. Okay. So it's good thing you are actually understanding what we are going to do here. Okay. Just open the chat. Box. Just finish share, right? So what Lilith has given, your name is Lilith, right? Yeah, Lilith has given, that is correct. Okay. I have no complaint on that. If of n is equal to if of hold on, let me go with that. If of n minus 1, so n minus 1 plus f of n minus 2. Okay. So if I want to establish this equation, that means I need to assume that f of n minus 1, f of n minus 1, it is actually returning the Fibonacci series of f of n minus 1, correct? We need to assume that f of n minus 1 is fine. Okay. F of n minus 1 is going to return me Fibonacci series of f of n minus 1. And similarly, f of n minus 2 is going to return me the Fibonacci number of f of n minus 2. Suppose I am into the nth position. Suppose this third is my nth position. Okay, that means f of n minus 1 means this, f of n minus 2 means this. That means I can assume that f of n minus 1 is always going to return me 2, and f of n minus 2 is always going to return me 1. Okay, that is my inductive state. That means f of n minus 1 and f of n minus 2 is a returning a Fibonacci series. Okay, that means fn is basically, if after that 4 is the fn I want to actually calculate, that means function of n minus 1 is 3, function of n minus 2 is 2. So summation of these two will be this number. So that's why the final state f of n is equal to f of n minus 1 plus f of n minus 2. Okay, so Nilanjan, all things actually have given a base step. Base step, I believe it's correct only. But whatever we have understood the inductive stage and this, is it correct? Have you understood until this? Before going to further, before going to write the program, okay, we need to go with this before I write something. Okay, we need to understand. Okay, now let's write the program. As I told, if I have detected the base case and assumption step, then rest of the program is just writing down those things like just function fib. Okay, now fib is n. I need to print up to n. Now what is my return? Return is going to be of n minus 1, n minus 1 plus fib of n minus 2. Okay, now I need to have a breaking condition, and breaking condition, what breaking condition? I will get it from my where base logic. That means if what is my breaking condition? If n equals to 1, then what should I return? Return 1, correct? So there is another breaking condition they have also given. So 1, if n equals to 1, I should return 1. Okay, I'll just go ahead with that. Okay, we'll do one by one. If n equals to 1, I should return 1. If n equals to what? 0, I should return what? 0. F0 is 0, F1 is 1, right? These are the program. Now, what I do in program, we try to optimize to reduce the line. Okay. So how can I do? See, if you read this thing, if I'm sending 1, then I'm returning 1. If I'm sending 0, then I'm returning 0. So what I can write? Okay, Dipanshu, let's go one by one. Okay, you have what you have done. I'll tell you what. So this syntax is called a ternary syntax. That's cool. You know the ternary syntax. Okay, but let's understand from the very base, because yeah, if you're doing it that, it's a ternary syntax. Okay, yeah, in programming, when you do a real life programming, we use too many ternary syntax. But here, what we are doing, we are understanding in depth what is happening inside that. Okay, I know everyone already attended the classes, and if you guys are CSS student, you know how to write Fibonacci series using recursion. Okay, so here let's understand in depth. Okay, yeah, so if n equals to 1 and n equals to 0, return 1. So what I can write here, that one thing I'm doing, because we need to learn this one also. If n equals to 1 or n equals to 0, okay, I have embedded this entire in a single form. Okay, then what I'm going to return, I'm going to return n. Okay, whatever it is actually coming, 1 or 0, same thing I'm returning. So it is n only I'm returning. Let's just wrap it up. I like to use more brackets. You can do without a bracket also. Okay, a return this, and this is your program for Fibonacci series. Now let's just run it. Let's comment it out. Let's just run it. Fib 5 and see what is happening here. Sorry, I need to keep a console.log. Fib 5. Let's see what is happening here. Fib 5 is 5. So 0, 1, 2, 3, 4, 5. Fib 5, where is 1, 2, 3, 4, 5. Okay, it is 5 actually. I'm looking for. That's that. 0, 1, 2, 3, 4, 5. It is running fine. Let's check with 4. It is running 3. That means my program is correct. Now let's go with 1. It will return 1. So all things are correct. Okay. Now we'll do some analysis using this Fibonacci, because in my factorial programming previously, what was doing, what it was actually calling a single function. Now in return statement, I'm calling a multiple function, but the things remain same actually. Okay, still we'll just do one analysis for that. Okay, what is happening here? Okay, it's a very small analysis, so we'll not spend much time here. So I'm not going to explain the call stack. You have already given the call stack same example. So here I have fib 5 I have written, right? In the first iteration, what will happen? Two things will happen right here. 5 minus 1. So I'm calling fib 5 minus 1, that means 4, correct? And here I'm calling fib 3, 5 minus 2, correct? So here again this 4, it will call fib function. This for this 4, what will happen? Fib 3, and what is happening here? Fib 2, correct? Now for this, it will again call two function, correct? One is your fib 2 again. One is your fib 1. One is your fib 1. Okay. Now your fib 2 and fib 3 again, I'll call it here. Fib 3 will go with fib 1 and fib 2. Okay. Again, fib 2 will go with fib 1 and fib 0. Correct. This is where it will start getting called. Again, this fib2 will same fib1 and fib0. This is fib1, right? So this will not break because fib1 always returns a 1. Okay. So what will happen here? So here, as per the call stack, JavaScript always execute the last one first, correct? So this one will get executed here. And in this case also, this one is get executed here because this one has the last one. Okay. Fib1 and fib2. So this one will get executed and it will put the value to 2. So now fib0 will be 0 and fib1 will be 1. So 1 plus 0, 0 will get executed here. So here I will have something. So let's write down here in the each step. So here in this case I will have what? I will have the fib2. I will have what? Fib1 and fib0. So 0 plus 1. I will have here 1. Okay. From this fib1, what will come? Another 1. Okay, so 0 plus 1 it came. Now fib3 it will go up and go give an answer to fib3. Fib3 now is having 0 plus 1 plus 1. Okay, this much is having from this left right only. Okay, and from the left leaf he is having what? Fib2 is okay, it's matched with further. Okay, so now as I told this fib1 and 0 again return. Again, this is going to return 0 plus 1. Again, you can here it will do fib what I call fib 0 and fib 1 1. Okay. Guys, am I audible? I think there is a power surge. Am I audible, right? Okay, cool. Fine. So what it's going to return here? It is return going to return 0. It is going to return 1. So together it will return 0 plus 1 here. And this 0 plus 1 will feed to this 3, 0 plus 1. From here it will come another 1. So 1 plus 0 plus 1. Here again it is 2. Okay. Now from here, this feed to 0 plus 1 plus 1. It's feed to here. So what is happening here? Many mess up here. Let's just for these 3, what we have here? We have what? 0 plus 1 plus 1 plus 0 plus 1 plus 1 only we have it here for these 3. These 2 also because there are 2 things. So this much I will get as a response for this fib3. Okay. And from here it will come 1 plus 1 because 2 only go 1 plus 1. So in the 4, what I'll have in the 4, if I think I'll have 1 plus 1 plus 2 plus 3. Okay, plus 5 by no, 5 will not be there. I'm counting from 0. 0, 1, 2, 3, 4, 5 will be there. Okay. This actually calculated this much. And from this fib3 also, the calculation will come. How much calculation will be there? This also be your 1 plus 1 plus, sorry, 0 plus 1 plus 1. Together it will match it here. In the fib 5, I have the full together. It is coming from net graph. This is coming from right up. If I mark it, what will happen? 0 plus 1 plus 1 plus 2 plus 3. Okay. Up to 3 it got. and it will have the 5 also because it's came 5 from here. Okay, so these are the exact all answer we get for the 5 result. Got it? So every step it will go ahead and keep on adding his own. Okay, and from the this last fib 0 will be executed first, then it will execute fib 1 and 2, then it will execute fib 3, Fibonacci 3. Similarly, from here, fib 1, 2 execute first, then it will go to fib 3, then it will go to fib 2. If fib 3, fib 2 get executed, return the value to fib 4, and fib 4 and fib 3 get executed and return the value to fib 5. Okay. So if you understood all the things what I have told previously for the factorial program, it is happening only same thing in a different leaf way. Okay, left up, right up. Is it clear? Everyone? Okay. Any more confusion up to that? Before that, we'll move this from Fibonacci and do some other kind of stuff, other kind of programming. Good. So let's just go ahead and do another small programming. What is this? Print increasing. Okay. So what is print increasing basically? So let's just see what is the output. Sample input is 3 and sample output is 1, 2, 3. So that means if I am suppose print IMCR, print increase. Okay. If I'm giving 1, sorry, if I'm giving 3, then it will, sorry, 3, then it will start calculating from 1, 2, 3, 4. Okay. Got it? Here. Fine. So now for this also need to go ahead and do my base case and other cases. Okay. How does that work? So let's just think about the base case. Okay. If I'm printing, if I'm going f of 1, what will get printed? Only 1. Correct. So that is my base case. Base case. So here one catch, we need to understand properly. How do I print increasing? Logic is very simple. Logic lies in the assumption state. If I can assume properly what I need to assume, then the rest of the thing is properly fine. So if I want to print 3, what I need to do, suppose let's take a bigger number, let's take 5. So what will be my output? 1, 1, 2, 3, 4, 5. Okay. So basically print CR actually represent my Fn. So what I need to assume, I always assume for Fn minus 1. So what I think, if I give F minus 1, then it will print 1, 2, 3, 4. Okay. That means if I give Fn minus 1, then what it will do? It will print 1, 2, 3, 4 as it is. Okay. This is my assumption step. So I understand that if I print F minus 1, then it will print F in my F up to Fn minus 1. That is my assumption step. I assume that it is true. Assumption. Okay. Now what is my last step? To formulate it. So Fn, what I'll do, Fn is equal to, it will not be equals to actually because we are not doing a summation or something. So it will be Fn minus 1. That will print up to Fn minus 1, and rest if I printed up to n minus 1, like if I have printed up to 4, then who is left here? 5 is left. That means I'll just use 5 Fn. Okay. Or n, if not Fn, or n. If it will not print, but will it not print 5 if we take n minus 1? Will it? How it will print 5? I'm thinking n minus 1. If my n value is 5, if I want to print Fn, that means it should print 1, 2, 3, 4, 5. Okay. Understand it. If I am trying to print Fn, then it will print 1, 2, 3, 4, 5. Okay. So to prove this, I told you we need to assume something. What I have assumed, that it will, if I give if n minus 1, then it is a true. That means if n minus 1 will print up to n minus 1. N minus up to n minus 1 what? 4. Correct? If n is 5, n minus 1 is 4. Correct? So if n minus 1 means 1, 2, 3, 4 will get printed. Okay, that is my thing. So after all printing is done, what I'll do, I'll print the last one, whatever the last is there. Got it? Is it clear? Okay. Anyone is having any more confusion on this before I move to the next one? Okay. So I'll do the same programming now. Okay. Now function your things here, and I'm going with n. So what I'm going to do, I have established that my if n minus 1 is going to print up to 1, 2, 3, 4. I know n minus 1 is going to print up to 1, 2, 3, 4. So what I'll do, console.log, sorry, not console.log. I'll just call pins here. Pins here in minus 1. Okay. After that, once it give all the things 1, 2, 3, 4, then what I need to print? I need to print the n. So let's go ahead and print console.log n. As simple as that. Got it up to this? We'll think about the breaking condition after that. Up to this, you got it? Got it. Now the breaking condition is always my break basic thing, like if 1 is equal to 1. That means if n equals to 1, then return 1. Clear? The breaking condition always my break condition. So let's just run it. See, 1, 2, 3, 4, 5. It's not printed 1 by, or I mistake. Didn't printed 1. It should return a 1. Why it is not printing 1? Ah, sorry. It will not print because it's not a return. It's console.log. Because I'm not printing yet. My consoles are here. So if I have given a return here, then it might think. It's fine. Maximum stack exceeded. What is the problem here? Why maximum stack? If I don't return, it will not. It will again go for infinite loop. It will go for infinite loop. So what is the problem? Yes. Thanks, Arina. I forgot to return. If I don't return it, this program will not stop. It will again go ahead and start executing the next line. And after something has exceeded, it will always go for exceeded. Okay. So we face this issue, right? So let's analyze what's actually happening if I'm not giving a return here. Let's analyze here. I got an error. What? Maximum call stack exceeded. Okay. What was happening here? Let's see. Let's do a dry run with this program. Okay. It's a good thing we have got an error. Error is always good. Okay. Let's just do a dry run. We'll understand this scenario, what was happening there. Okay. Let's it's a stack issue. Let's draw a stack here. It will be more clearer to us also that what went wrong. Let's draw a stack here. It's a stack. It's my stack. So what was my function? Suppose let's pn, is printing in. Okay. In my case, what it was doing, it was actually going with, let's go with print 4. It should print 1, 2, 3, 4. So it's entered into the program. After that, what it got a pn minus 1. That means it got a p3. So first I put p4 here. P4 here. Okay. After that, it got what? P3. P3 here. After that, from P3, what I call P2, correct? It got P2 here. Okay. After that, what I got? P1, it got P1 here. Okay. And inside the P1, what I have written, I told that if P is equal to 1, then do a console. Console.log 1. Okay. After that, what happened? It go for again Pn minus 1. Now 1 minus 1 0. So it will go for P0. Okay. Then P0 will be pushed here because there are no return. Again P minus 1, P minus 2, P minus 3, P minus 4. Is there any stopping? No. It is going and going and going and going. And at some time for point of time, it will exceed the limit. Okay. So that's why we got a problem. Now, amazing thing we got it for. See, P1 was having a console.log 1. Okay. So that is also a property of JavaScript. JavaScript is the interpreter. That's also we also can prove. See what we got. We got 1. 1 has been written, right? Because this up till this console there are no error. So it printed a 1. After that, when it checked that there are no stopping, it told me maximum stack size exceeded and terminate the program. Got it? So JavaScript also interpreted is also read line by line and stack by stack. The moment something enters into the stack, it's popping and executing. Okay. So that's how you also understood something like this. Okay. So now whenever I give a return, that means function execution ended. Okay. So I will tell you one more thing in this context. Again, it is not a part of your recursion. So it is a part of your JavaScript only. So that's called an execution context. Okay. So basically, when I'm actually writing these blocks, okay, these blocks, what are those? These are actually execution context. Context. Okay. And what kind of execution context? It's called a functional execution context. We must have a class before that. A class. You have got it or not? So functional execution context. I think you have got it, or you will be getting in later point. So every time JavaScript want to run some function, it create a functional execution context. And whenever you return it, then only the execution context is ending. If you don't return it, it is not getting a proper return. It will be in this execution context for infinite time. So that's why when I didn't return it, so it is keep on calling. So if I return it from here, then execution context is ended. Okay, unless if you don't return it here, it will again go to this line and start running this also. Okay, that's the fundamental thing of execution context. So in JavaScript, you have two kind of execution context. One is your global execution context that happens whenever you are actually running any global function, and the functional execution context is only for your functions. Cool. Fine. Now, any question, any query on that before I move to the next program? Any problem? Cool. So let's go to the next program that is the exact opposite that of this. Okay. So we'll keep this one only. Okay. Now my question is print decreasing. I was printing like this. Now I have to print like this 5, 4, 3, 2, 1. Okay. Now you guys tell me how to do it. How do I do print decreasing? So let's go one by one. Let's just tell me the base condition first. Okay, it's up to you guys now. Tell me the base condition. Okay, Suraj, you told n is equal to. The question is in decreasing order. We have printed in increasing order, right? Now we need to print in decreasing order, like 5, 4, 3, 2, 1. This way, it's called a print decreasing. Okay. What is the base condition here? Okay, Sharad is telling n equals to 1 and Bharat is telling n equals to 5. Okay. Okay, hold on, Niranjan. So Sharad and Bharat, can you guys unmute yourself? Let's have some discussion here. Sharad, you are using proper mic. Can you?
Yes, sir.
Okay. Okay, and Bharat?
Yes, sir.
Okay. So Bharat, tell me why you think the base is n is equals to 5?
Because, sir, we next step n minus 1 given. Now we give n plus 1. And we stop the function n equal to 5 when he complete the all recursion.
No, I don't want in the first phase to execute all the things. So what you have done, you have actually assumed entire programming. Okay, not like that. Assume what is a base case. Okay, so I asked about the base case. Base case means what? Which I can completely sure that it will always be true. So you have done 5 if 5 is equal to 5. So this 5 can be n, right? 5 can be 6, it can be 7, it can be 8, it can be n. So for if n, can I assume that what will be my output? If you're giving a 5, n is equal to 5, that means it is 5, 4, 3, 2, 1, right? So in case of 5, there can be 6, 7, 8, 9, 10, n number of things. Okay. So is it, are you, now you think, what do you think? It's a base case. Base case is something which you can calculate in mind and it can be always true. Okay. So if you think about 5, it's not a base case. Why? This 5 can be 6, it can be 7, it can be 8, it can be 100. Right? So it's not a base case. Are you clear now?
Yes, yes, yes.
Okay. So Sharad, you told the base case is 1. Yes, base case is always 1. Why? If I give fn is equal to 1, instead of that, if I tell you to print decreasing number up to 1, from 1 to 1, from 1, print decreasing number from 1. You know the lower bound is 1, upper bound is 1. Which one is get printed? 1 only. Right? No matter what condition or what environment will be there, if 1 will always be 1. So that's my base case. Okay. Now let's go back and think about that what we have previously thought. We have previously thought for increasing what we have thought. Assumption what we have thought. We have thought that my if n minus 1 is going to print 1, 2, 3, 4, 5. 1, 2, 3, 4. Like if n minus 1 will print the increasing thing, like whatever the things I have up to n minus 1, it will print. And last, whatever left, I'll just put it back there. Okay, 5 was left, 5 I have put it back, and that creates a 1, 2, 3, 4, 5. In this case, it's a reverse order. So assumption I can do like same only. What I can assume, let if n minus 1, what will you do? Let n minus 1 print all the things here. Okay. Now n minus 1 will print 4, 2, 3, 1. If n minus 1 let print 4, 2, 3, 1, I'll just put the n on the top. So what will be there? It will be like this only. If n, I'll first print the fn, no matter what I'm getting, the upper bound, I'll print it and put rest of the thing to my n minus 1. The rest of the thing will be printed by fn minus 1. So if you go to this programming, what I'll do, I'll just take it from here and put it here. And that's will be a decreasing thing. Okay. Base case remains same. If n equal to 0, it will print till the 1 to 5. I'm not getting what you are telling, it will start printing from 0 then. My intention is to print from 1. Okay, I don't want to print it from 0. If you think about base case as 0, there is also a base case, but they will start print from 0, 1, 2, 3, 4, 5. Okay, but I don't want that. I want 1, 2, 3, 4, 5. So my base case and lower bound is always be 1. Okay, so here what I'm doing, I am getting 5 here. Okay, I am just printing 5. After that, I'm going with 5 minus 1, 5 minus 2, 5 minus 3, this way. So let's just see what happening here. Print it. Okay, sorry, I not. Okay, see 5, 4, 3, 2, 1. Now, if I go to the whiteboard, okay, and start writing things, what will happen here? So let's go there. This is my stack. Okay, and I have called F5. Okay, what is happening? First F5 is printing going here. Okay, F5 is printing 5. Okay, after that, what is doing? It is calling F4. Right, after printing on, it is calling F4. It is calling F4. Now F4 is here. Okay, after that, it is called F3. F3 is here. Then it will go F2. Then it will go F1. F1 will actually return 1. So it will go problem here. So in each of this, it will print 4. It will print what 3. It will print 2, and it will print 1. So 5, 4, 3, 2, 1. Printed everywhere. Okay. Guys, just give me 1 minute. Okay. My system is actually fluctuating. So in any case, if you think I lost my connection, just wait for 2-3 minutes. I will be joined back from my backup. Okay. So it will just take 5 minutes to do in a backup. Okay. Fine. Just 2 minutes. I'm coming back. I just need to bring some water. Water up in it. Okay. Okay. So guys, I'm back. We cannot have dinner break because it's a 3 hours class completely. Okay. Just wait for 5 minutes. So let's do one thing. You can take a break until 10. If you wanna, anyone wanna take break until 10? Because I can give you a maximum 10 minutes of break only. Because we have some other programming concept to cover. Okay. Then let's take a break. Let's take a break. If you want to go to washroom or make yourself refresh, then 15 minutes you cannot have. We need to, it's a revision session, right? We need to have many more things here to cover within 11. Okay. So let's go. Let's just take 10 minutes now from now. Okay. We'll start very slowly so that whoever is coming little late, they can also catch up. Okay, let's go back. Hey, hello guys. Whoever joined, just ping me in the chat. Joined. Okay. Weather is very bad here. Okay, guys. Let's start to our next segment. So basically, conceptual understanding we have. So in this segment, what I'll do, I'll go one by one and solve one, two problems with you. Okay. So as I told here, weather is not good. So whenever you are thinking that my voice is not audible or you are not able to hear it clearly, please ping me in the chat so that we can check that one. Okay. So let's share the screen. Okay. So next problem with recursion, what we need to do, we'll be checking that whether a given array is sorted or not. Okay. So we all know about arrays as we are going in the JavaScript. We know about the arrays. So I believe that you have a basic understanding of how array looks like. So we are not going to go in depth by teaching you the basic fundamental of array. So let's just give you an array. See, so this array looks like this. So here 1, 2, 3, 4. So suppose I have 2, 3, 4, 5, 6. So we need to check. So let's have another array here. Okay, like 5, 2, 1, 4, 9, 0. So what is the difference between this and this? So this array is sorted and this array is not sorted. Okay, what do you mean by that? So if you think about that, it is going as ascending order, like 2, 3, 4, 5, 6. Okay, so this is ascending order sorted array, and it is here 5 after 5 is 2, that's 1, after that again 4. So this is a unsorted or not sorted array. So we are concentrating on sorting an array on ascending order. Okay, so in this class or in this program, we are not going to sort this. Okay, we are going to detect it whether the array is sorted or not. Okay, let me open the chat again. So I believe whoever joined recently, just tell me join in the chat so that I will understand how many of them you guys are actually catching up with me. Okay, so let's understand in base way. How do I check is the array sorted or not? In a sorted array, this element always be greater than this element. Again, this element always be greater than this element. This element always be greater than this element. So each element is greater than the subsequent element of this array. Okay, so that's how it is sorted. Now, how do I check it whether it is a sorted or not? Let's think about a very small array. Okay, like this and this. Okay, so suppose I have here 1, I have here 2. Okay, this is my 0th position, this is my 1 position. How do I tell that this array is shorted or not? I'll check, suppose this is array A. So I'll check A0 is less than A2. If it is like this, then it is shorted. Clear up to that? Clear? Everyone, am I audible? Please ping the chat. Yes. So it is clear. How do I short a very short array? In which language? I'm not getting your statement. In which language audible you works? Okay, fine. So here I have a two element array. So I can short it like this. I can check this is a shorted or not. Okay. But if I have a large array, I cannot do like that. Okay. So if it is a 5 element array, so each, I'm not sure how to do it. If it is a very short array, then I can do it. Okay. So now what will my assumption and what will here when I am doing a recursion? Okay. Suppose I have this array. Let's just go ahead and delete this part. Let's understand properly what I'm telling here. Okay. After that, if you go into programming, it will be very easy. If I'm having an array of these 1, 2, 3, 4, 5. If I somehow assume that this array is shorted, okay, if I'm assuming this particular array, leaving this, if this array is shorted, then how do I know that after adding this will be shorted? How do I know? This is a 0th position of this array ARR, and if it is a ARR 2, this is its 0 position. See, now if ARR 1 0 position is less than ARR 2 0 position, if this condition met, then this entire linking array will be shorted. Clear? Everyone, if you have any confusion in this, tell me. Ping me, guys, otherwise I'll not be able to understand. So what happened? Everyone is tired. Okay, let's repeat again. I have a this much array. Okay, I'm assuming that's 2, 3, 4, 5 until this. Okay, hold on. I'm assuming until this particular array is been shorted, and this name is ARR2. Okay, so if I link this one last element to this array, it will be shorted or not. How do I know? So suppose this array is, this one is ARR1. Okay, so ARR1 is 0 position is this one, ARR2 0 position is this one. So if this one is smaller than this one, then only the linking array, merged array will be a shorted one. Correct, Suraj? That's why I've written ARR10 is less than ARR20, then only it will be a complete shorted array. So here, this one is my assumption. Okay, I'm assuming that this part of array will be shorted. Then I am checking whether this one which is coming new is shorted or not. So that is my assumption step. Okay. Now, what is my base case? What is my base case here? If the array is only having one element, okay, if the array length of array is only having suppose I have this much array and length is 0. Sorry, length is 1. That means I have only one element. Then it is always sorted. Correct. This is my base case. So let's go there and write down all the things. Base case what? If length is 1, then it is always sorted. Okay, that is my base case. What is my assumption? Let's just see how it is done here. Assumption is other than the first element, rest of the array is sorted. How do I detect that? How do I, so now how do I get the rest of the array here? Let's just go to my whiteboard. Okay, so suppose I have an array here. Okay, 1, 2, 3, 4, 5. I have an array here. This is my 0, 1, 2, 3, 4 position. Okay, so how do I take this much array? If I am denoting this via I is equal to 0, then I plus 1 will be this one. So from I plus 1 to length will be my this rest of the array. Correct. So my index will be I plus 1 when I'm taking the rest of the array, leaving first one. Correct. Is it clear? So I'm just stopping it here. I believe if someone else joined and didn't know the context what I'm teaching, please ping here so that I'll just give you a rough context what I'm teaching here. What is my problem here? Okay, no sign, that means okay. I believe everyone understood what is there. So this is what I'm going to do it now. Fine. So my assumption step, I have done it here, that it is sorted for I plus 1, where I denotes position. Okay, so this is my assumption step. It is completed. Now let's just is sorted. Is sorted is my function. I'll have a let arr is equal to 1, 2, 3, 4, 5. Let's just defining an array in JavaScript, passing this array. Now I am going to write is function's definition is sorted. Okay, and it is taking an array. So what I told, I have assumed. So let value, I have taken that one is sorted function will return me all the things properly. So is my assumption is sorted. Okay, so let's just take another thing here. I'm just taking a position also, like from which position I should start traversing. So here arr I plus 1. Okay, as I told that here also you can see this is I, and I, if I want to take this array as an assumption, I'll do y plus 1. That means here arr I plus 1 is there. Okay, now this is sorted. I'm assuming this is sorted. If it is not sorted, it will always return me a false. Okay, now if value, that means this value, that means this array equals to true, that means it's sorted. And what I need to check the last condition I told, that this one, that arr new arrays 0 is less than the old array's 0th position. That means what I have here is ARR I less than, just let me check, it's a I plus 1, right? Yes. ARR I plus 1, you value an ARR I plus 1, this is also a condition. If it is true, then only it will return true. Then what I'll do, return true, else I'll return false. Okay. This is a function I have done. I didn't have a breaking condition. Now, how many of you are there still with me? Please give a heads up, yes or something. If you have any issue on that, tell me. I have a confusion in this line. Any confusion? If condition, please explain. Okay. What I'm doing, let's break it out first. So let's just remove this one. If I'm telling you value is equal to true, you understand? That means it is coming. If this array is shorted, then only the value will be true. Hariharan, understood this up to this? Okay. Then another condition, what I need to check, not only this array should be shorted. After merging this, that means this one, this I and I plus 1, this is the I position and this is the I plus 1. This is this position and this position. So this position should be lesser than this position, correct? Then only the array, complete array will be shorted. So that's what I am going to write here. That means my ARR I less than ARR I plus 1 plus 1. Okay. So if it is true, if this thing is true, then only it will return true. If both are true, it's an AND condition. If both the values are true, then only it will return true. If any of them are false, then only it will return false. I'll give you a shorter way to do it also, but for now, let's like this way only. So now what I need to do, I need to keep a breaking condition, because if I do it here, it will go for a maximum stack. So can you tell me, can anyone tell me what will be the breaking condition? What will be the breaking condition? Anyone? What was our base logic? It is always true if the length is 1. Now tell me, what is your breaking condition? No. So what was my base logic? Length, if the length is 1, then it is always shorted. That means it is always true. That means if ARR dot length of array, okay, ARR length will not be there. Yeah, fine. If I, so every iteration, I am actually increasing the ith value. Okay. If you think about this way, previously i's value were in this case I value was 0, then I value were 1. In this case the value of I is y1 2. Here it will be 3. Here it will be 4. That means when it's reached here, that means it's one element left. That means this one is always shorted. That means the value of I is 4. What is 4? This length 1 2 3 4 5 minus 1, length minus 1, length minus 1. Okay. So if I write it like this way, if array I equals to length minus 1, then what will happen? Return true, always true. So because I means 4 and it's in the last position, that means all are fine. Yeah, Ankit, correct only. Okay. So this is what it's there. Okay. So this is my breaking condition. Now, instead of writing this many code here, I'll just write in a very smart way. Okay. Return. So long ago, some time ago in the first class, someone actually told a one-liner statement. So instead of doing all things, I can do a one-liner statement here also, value and ARR II plus 1. Basically, this is also can be represented by a one-liner statement. Instead of doing entire if else all things, I can just simply write this. Okay, then value and if these two are true, it will return true. If these two are false, it will return false. Okay, so let's check. This is my small program currently now. So let's just check whether it is working or not. So 1 2 3 4 5, it should be shorted. Okay, what is the issue? Maximum call stack exceeded. Any issue I have done? Array dot length, will it be in a bracket? Yes, it will be in a bracket, otherwise it will not work. No, still happening. What is the problem? Length -1 is true only. Hmm. Any mistakes I have done here? Return in line number 20. Yeah, I have returned it. Full otherwise bracket. Okay, let me try it out. Whatever you are telling, you are trying this. Let's see. Still giving unrecovered code. Let's see. No, there are some mistakes is there. Unexpected token. Okay, that's a different issue. Hold on. Let me write from the very fresh. Okay. Now here, I+1. Let's just give it like this. A semicolon is not needed in case you are doing something like this. JavaScript doesn't work with semicolon. Here. Now all clear. Now let's see what is happening. Now I'm getting same error again. What was the code here? Okay. When I'm calling, I need to call it like this, right? Is shorted 0. I'm not giving any index. That's why it is getting failed. So my function required an index from where I should start. When I call the is shorted, I should start from 0. So that's what I need to give a 0 here. See, now it is actually telling running infidel. That's fine. Now I need to do a console. Is shorted array 0. Okay, let's just run it. True. It is working as true. Fine, it's sorted now. Thanks everyone. Now if I make 2 and replace the 1 here, that means now it is going to return a false because it's not a shorted array. Let's try it out. The output false, again false. So it is working. Okay, so clear. Any other question? Line number 16. Okay, line number 16. Yeah. So it is telling if I equals to array dot length -1. So what I told that let's just go back to my dashboard. Length -1, I'm going. Okay, let's just tell you what is here. Sorry, hold on. Okay, so what I'm doing here, I'm just writing an array. Okay, so it is 0 1 2 3 4 position. So here 1 2 3 4 5. So what I told, if the length of array is only one, then that means it is shorted. When it will be length of array, so if you see our code, in every iteration I am doing I plus one, like, so first iteration it will take 0, that means entire array. Second, it will take up to this. Third, it will then up to this. So if I go with like that, in the fourth, when the i's value is 4, that means that time it is having only one element, correct? If the I value is 4, the value of I is 4, that means it is having only one element. Now, how do I know the i's value is 4? If it is a 4 length array, 1, 2, 3, 4, 5 length array, 1, 2, 3, 4, 5, then the last index will be always 4, which is actually, suppose the length is equal to n. So the last index, what will be there? Last index n minus 1. So that's what we have given. So array dot length, length is equal to n, length, suppose length is equal to 5, and the last index is 5 minus 1, which is a 4. Okay. So if I is equal to 4, then it is going for a last, and it is only having only one in length, only one element or one length array. So that's what we have done. If I equals to array dot length is 5 element, array dot length minus 1. Total element n, last index n minus 1. Yes, correct. What is len count 1? I'm not getting Suraj. What do you mean by len count 1?
सर लेंथ काउंट 1 से होता है ना, 0 से नहीं होता है, ये कंफ्यूज था। हाँ,
Length,
ये सर ये
it is clear now.
हाँ सर क्लियर।
Okay. Okay. So Rupesh, I didn't get why we wrote line 20. So line 20, if you want to know line 20, you need to know what is our assumption. What was our assumption? I assumed that it is shorted. So it's actually in better way to tell. I assume that if I give a I plus 1 in is shorted function, then it will return me the array is shorted or not. That I have assumed. Okay. So that's why array I plus 1. That means I have assumed, see, suppose if you see this array, what was my assumption here? My assumption here, so this much is what? I plus 1. So it is, if it is a I, it is starting from I plus 1. That is clear. Okay. So it is an array starting from I plus 1. So my if shorted will return true if this is shorted. That is what I assume. And my is shorted will return false if it is not shorted. Okay. So that's why I have written the line number 20 is shorted. That means I have given the array and I've told the array to iterate from I plus 1, and it will return me true or false depending on the array is shorted or not. And I assumed it will always return true. If it's array shorted, it is always return false. Hello, Suraj, Rupesh. Okay, Rupesh, you are not understanding, then speak. You can unmute yourself.
Yeah, hi sir.
Okay.
So basically I'm not getting, sir, like why are you taking the condition of value to be true? Like is sorted is the function which is mentioned in line 14, right?
No,
So-
I'm not getting true. Okay, I'm not taking true. It can be either true or false. I'm just assuming it will return proper. If the I
Okay.
plus 1 is true, like if the array which is starting with one position is shorted, then is shorted will return me true. If the array is started from I plus 1 is not shorted, then is shorted will return me false. That's what I'm assuming. I'm not assuming that it will always return true.
So sir,
Yeah.
how are you considering that is
This is
sorted
my
means the array is sorted or not? This line 20 will return us if the array is sorted or not. That condition it will return us. How can you say that? I'm not getting that basically of line 20.
What do you assume? What is your assumption? What is the meaning of your assumption?
Okay, okay.
Go a little
So
back.
that is-
Mathematical induction. Every time, second step, we assume.
Okay.
Okay, that's what we assumed. We assumed. It's my assumption that it will always be true. On basis of that, I have written the line number 2.
Line number 20, you're saying.
Yeah, line number 20. On basis of that only, I have written the line number 20.
Okay.
On
so,
after that, inductive stage I have done in line number 21.
no, I don't have any problem with line number 21. I can understand that. But in line number 20, suppose even if you've assumed that, then how can you get the sorted array? I'm not getting that thing. Like in this line number 20, how can you get the sorted array? That is my question. Like you're taking the array as ARR, which we are giving the array. And after that, you're starting the count from I plus 1, right?
Okay.
Hmm.
Let's go into deeper then.
Yes, yes. Thank you, sir. Yes.
Okay, fine. Let's just write down whatever we are doing here. See, if you understand the stack, you will understand here also. Okay, so let's just write the same problem here.
Okay.
Okay, what was I have? 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4. This is my i's position. Okay, what I'm calling here first is sorted. Let's just telling it s. Okay, s is my function. So s is taking ARR and 0 first, correct?
Yes.
So i's value is 0. Condition, breaking condition is not meeting. So what it is doing from here, it is calling what? It is calling another is sorted.
Okay.
If you think about this function here, after that it is calling another is sorted. And in this case, what is taking? S, same ARR. Now it is taking 1.
Right.
Okay. Now it is taking S, ARR 2. After that, it will take what? S, ARR 3. Function is not completing, right? So let's just go until this.
ARR of 4.
Okay, let's go S, ARR 4. Okay. Now, what is ARR 4? Whenever I'm calling ARR 4, i's value is 4 and length minus 1 4. That means what is it returning? It is returning what? True. Correct. This function will return true. Why? Check the condition here. I's value is true. So if I is 4 here, if I'm taking I4, that means 4 here it will be 4. And what is the length? Array dot length is 5. Correct. 5 minus 1 what? 4. 4 is equal to true. Return true. Correct.
Okay.
It has returned true here.
Yes.
Now, when it returned true, it will go back to this function.
Right.
Now, what is the value of this function? So in the value, I have given a value, right? What is the value here? True. Correct.
Yes.
It is calling is sorted true. Value is true. Now value is true. Fine. And what is it is taking? ARR I less than ARR I plus 1.
Okay.
Now value, it got true. Now in this return statement, what I have written, value is true, that true, fine. And what is now doing? ARR I. What is ARR I in this function?
0.
No, 3. ARR I means ARR 3. ARR 3. That means this 4.
Yes.
ARR I plus 1. That means this 5. 4 less than 5. True.
Yes.
Both are true. What it is returning?
True.
Entire function true. This true will go to what? This true will come to here, this array. Correct. Now, same thing will happen here. Correct. Array's value is now the value what? It is coming as 2 here. So this condition will not be true. It will go ahead and run the if sorted with another thing.
Yes. So sir, can you
Similarly,
explain the if sorted case in which it will go into if sorted? The 2 will go into if sorted, right? So
yeah,
again,
2. See, let's understand. From 3, value is true. Okay.
yes.
True. So from ARR 3, what it got returned? It got returned in the ARR 3. It got returned true, right?
Yes. Right.
So this true will be passed to where? Line number 2. In which line? Line number 20, where value is equal to something. So here in line number 2, what will be there? Value is equal to
2.
this value is coming from here. Yes, it will be true. Again, it will go to its next line where it will check what? 2 versus 3. That means 2 is
Okay.
here, 3 is here. It is
Yes.
shorted or not? It is again
Yes.
shorted, again true, true matched. Again, it is here getting us true.
True.
Okay. True, again will match.
So
And
1
it will,
with 2 will match. After that, 0 with 1 we will match. Yes.
Yes.
Got it.
got it. So that's why,
Sir, yes. So, sir, just one thing I would like to say. So, sir, first we are considering the last case, right? Like in the
Yes.
function, if you show me the code once.
first it is considering the last case. That's why
Last
I have,
condition.
that's
Yeah.
why I trickle equals to length minus I means the last one, last condition.
Okay.
So that's
Okay.
what I was doing that the first time. The last array is shorted. Last array, if I am assume this is my base case. In base case, I have
Right.
taken this is shorted. And
Right.
assumption is I have assumed this is shorted. And
Hmm.
each step, what is happening, I am keep on
Comparing.
proving. Yeah, comparing. Now these two are shorted. That means I have assumed not shorted. I am assumed that my each shorted will give a shorted return from here. Okay.
Yes.
Once I am going there, now I got these 3 are shorted. Now I'm assuming, okay, these 2 are giving a shorted array. Okay. Again, next step, this one got getting here. Now I'm comparing this one will giving a shorted. Now consider if any case, if it was a 4 and it was a 3. So any case, if it is a mismatch, then this second
False.
condition will get false, of course. Okay.
And
If one
false
condition
and
is false, false 2 is always false.
Yes.
Okay. So that's how we have designed this thing.
Sir,
Clear?
once more, please show me the code once.
Yes, of course.
Okay. So in the start, how is it going inside the if condition? Can you explain me that?
In the start, first
Yes.
always it will go to the if condition, right? This is the first if condition.
Okay.
Okay. The i's value is what? I's value is in the first, when I call it from here, i's value is what? I'm giving i's value as 0.
Yes.
Okay. So it will not go inside if condition.
Okay.
I plus 1, it will not go. 2, 3, 4. Whenever i's value is 4, then only it will go inside the if condition and it is
Right.
it will break the recursion.
Yes.
Okay.
So how is it going inside the if condition? It will go in the end, right? Like we
Yes,
are
in
first
the end.
executing this 20th line. So inside that it is checking for the last condition, and then from last condition it is coming down, right? So
See, it will not. See, first of all, when i's value is 0, it will not even go inside this. It will directly
Yes,
go
right.
and dial this.
Yes.
It will keep on running until the i's value is 4. Whenever the i's value is 4, it will go into len number 17 and return true.
Return true.
Okay.
And our
Then
is sorted.
subsequently, yeah, each shorted will return a true. Here, each shorted return a
For
true.
the value of 4.
Yes, for the value of 4, it will return true. Then
Yes.
when I get the value of true, I'll again check the value of true and the ARR I and I plus 1. On that moment, it is in ARR what? ARR 4 is shorted I3. I4 is already true.
Yes.
And I3, in I3, what it will check? 3 versus 4.
Yes.
Okay. Then if it is true, then true to return true, and this true will go to next phase.
No, sir. Please wait. Over here, whenever, like you told that whenever it is returning true, right? Like whenever our value is returning true, at that time, I is the last index, right?
But if it is returning true, it is not going to this line, right? So i's, if the i's value is 4, this entire line is not running for i's value is 4.
Okay.
Okay. See, if I'm giving here, if he's going here, see, suppose I don't have a if condition here, what will happen? I4, i's value is 4, and I plus 1 is 5. So ARR 4 and ARR 5 will compare. So there are no ARR 5 actually, correct?
Yes, right. Yes.
So in the next iteration, when the value, in the next iteration, what will be the i's value? I value will be 3, right?
3,
value
yes.
of I will be 3. If the value of I is 3, then this condition will not get passed, correct? It will directly come here. Now I got the value of shorted from this condition, previous condition, check the recursion. Error, this one is true. This one passed the value to this one,
Right.
ARR 3. So ARR 3 already have the value as true. what you need to do, you need to check the condition. So what is checking? ARR 3 versus ARR 4, I versus I plus 1.
it is checking.
Okay.
Yes.
If it is true, true is true, returning to next phase. ARR 2,
Yes.
2 to 3, 3 by 2, 2. If it is true, true. If it is false, true, false, return value will be false in next phase. So if one value is false, or automatically all the value will be getting false.
Done, sir. Got it. Totally got it. Thank you, sir.
Got it?
Thank you so
Okay,
much. Yes,
fine.
yes. Thank you.
Cool. Anyone is having any other confusion before we go to our last segment? Cool. I believe everyone is okay. So let's just go to our last segment. What is you have written? I'm not getting Ankit. What is this, Ankit? Ankit, what is this? Okay, so don't only return that as true. Okay, follow the program that I have given. Okay, Ankit, no, it is not right. You will fail in some cases because you have written a 2 cases. Okay, check whatever I have written here. So I have checking value and this. Both the things should be true. If one is true, that doesn't mean that entire array will be true. The previous check and the current check both of them should be true. In your case, you have returning false whenever you are thinking all things are false. Okay, that is also fine. Here you can return false, but where is the return true? That is not also there actually. So follow this program only. It will always it will cover all the scenarios. Okay, last program for today. We'll go with a very interesting problem, interesting solution. Okay, it's a grouping solution. Okay, now grouping solution, even though if you don't even understand the program is very easy. Okay, program we don't need to worry, we don't worry about this, but understand the concept, understand how we do without a program also. That is very important here. What is grouping problem here? So it's called a friend pairing problem or grouping problem. Okay, so suppose I have 3 friends. Okay, one, I have 3 friends here. Hold on. 1, 2, 3. Now these 3 friends are actually, suppose these are number of this. Suppose they are, if they are player, football player, these are their jersey number. So how do you group them uniquely? That means, let me see, how do I group them uniquely? I can group them like this: 1, 2, 3. That means 3 groups are there. Like 1 is going along, 2 is going along, 3 is going along. Or I can give it like this: 1 and 2, 3. That means 1 is going along and 2 or 3 is going as group. Okay, I can go like this: 1, 3 and 2 is going along. Okay, and what else I can do? 1, 2 is going and 3 is going along. Okay, these 4 cases is possible, right? Any other cases you can think? uh, 1, 2, 3 I have given. 1, 2 and 3 all are 1, 2 and 3 all are separate. Full group will not be possible. Full group will ignore, like 1, 2, 3 full group not there. We need to group it either individually, either with someone else and individually, someone else and individually. Okay, any other possible? No. Yeah, it's not. We again think we'll not consider the permutation. That means you don't tell me that 2, 1-3 is also a combination. No, we'll just check the combination, not the permutation. Okay, and yes, it can also call combination without a repetition. Cool. 1-2-3, 1-3-2, 1-2-3. These are the 4 conditions. Now, as the number is very less, I can do it without a problem. Okay, suppose I have here mode here 5, 6. Now doing this will be a headache. Definitely, if I am not very careful, if I'm not following a rule, I may miss some of the things. Okay, so let's just follow a rule to create this. How do I follow a rule? So before going to the programming, I need to think in my brain that how do I follow a rule. So I am telling this one is my key player. Okay, what he'll do, either he will go along. Okay, first of all, let's just take 2 and 3, sir, or 1 and 2. If I am having a 2 people, so what we have, so either they can go 1 and 2, or they can go 1, 2. So if the number is 2, number of player is 2, then there will be always 2 condition. Okay, what it is looks like, it looks like a base for me. It's a base condition. If the number of players are 2, then always 2 combination is possible. Okay, now let's go with that. So I'm telling this is my key player. He will either go along or he will go with any of the pair. Okay, that means any of the pair means he can either go with 2, 1, 2, either go with 1, 3. Okay, this is my condition. Okay, or he can go along. Okay, got it. Or he can go along. Okay, if you think about here, so here I'm telling if he is going pairing with 2, here I'm is going pairing with 1. Only one condition is possible, but here there are multiple condition is possible. One is linked to it 2, 3, that is okay, but 2, 3 also can have 2 more condition, right? 2, 3 can be grouped, and 2, 3 also can tell we will go individually. Correct? Because 2, 3 can be grouped, can be they can go individually. Okay, so now this is my thing, this is how we do it. So now if I try to calculate, how do we calculate? 1 is my key element. Okay, if 2 and 3 is, if he is grouping with 2, then left, who is left? 3 is left. If he is grouping with 3, who is left? 2 is left. Okay, so from here what I'll get, 1 to a group, and who is left, she will be alone. 1, 3 are group, then who is left? 3 will be along. Okay, here where I'm getting 1 and 2, 3. 1 is along and 2, 3 is group. And another thing, another variant of 2, 3 is 2-3. That means 2 and 3 also can go along. So if 2 and 3 are telling I'm going with individual, then 1 will also go as an individual. This is how I calculate it in a systematic manner so that I will not miss anything. Clear? I'll go with 4 step also. 3 step is clear. Everyone, if it is not clear in 3 step, we need to explain it. Okay, fine. Let's go with 4 step now, 4 variable now. Okay, now let's go with 1, 2, 3, 4. Okay, what we'll do here, same, 1 is a key element. He can either go with single, either he can pair with any of them. He can pair with 1, 2, he can pair with 2. Correct? He can here pair with 3. He can here pair with 4. Okay, if he's pairing with 2, then who else are left? 3 and 4 are left. 3, 4 are left. Okay, Now 3, 4 can go as 3-4, or also they can go as 3, 4. Correct? Two variant is possible, just like 2. Similarly, 1, 3 is there. That means who left here? 1 and 3 I have given, and 2 and 3 is left. 2, 3 can either go together, either go individually. Okay. And in case 1 or 4, that means 1 and who left here? 1 and 4 I have taken. Okay, here I have taken 1 and 3. That means 2 and 4. Sorry, yes, thanks, Hariharan. 2 and 4, 2 and 4. Here 1 and 4. That means who are left? Yes, 2, 3, or 2, 3 in a group. Okay. If you think about this, here 1 is there, and 2, 3, 4 will be there. Okay. Now, what else can be here? If 1 is along, then 2, 3, 4 can be there. Then what else can be there? So from 2, 3, 4, what we can have? From 2, 3, 4, we can have 1, 2, 3, 4. That is one possible. 1, 2, 3, 4 we will not have. So it's all 3. From 3 we can produce more 4. So what we'll have here, we'll have 1, 2, 3, 4, 1. All are actually going along. Then what I can have, 1, 2, 3, and 4. These 2 can be done. 4 can be along. 1, 2, 3, 4. All things we have already having here. Okay. Now let's write it down. 1, 2, 3, 4. 1, 2, 3, 4. Now from here, what I'll have, 1, 2, 3, 4, and 1, 2, 3, 4. Similarly, from here also I'll have same thing. 1, 3, and 2, 4, and 1, 3, 2, 4. So you understand that you can calculate each and everything here. Okay. Until this, how are I calculating this thing is clear. Then I'll go to a simple formulating thing. Is it clear, everyone? Then I'll go with an formula. Everyone, if you understood response, then I'll go and proceed. Or any confusion, also respond. Okay, fine. Now let's take and try to make a formula here. How do I make a formula? Because what they told me, they don't ask me, see in the question, they don't ask me how many, what are the combination, write it down. My only responsibility is to find the number of calculations. So I'll just do a calculation here. How do I detect the number? So let's just see. If you think properly, you can actually formulate one thing. 1, 2, 3, 4. Okay. 1, you leave it. Okay. If you think about 2, 3, 4. Okay. From this, how many combination possible? As I thought, 1, 2 is there. 1 combination, 1, 2. So the 3, 4 will be left. 1, 2, 3, 4. And another one is what? 1, 2, 3, 4. 2 combination, right? If I merge with 2 combination. If I merge with 3, again I will get 2 combination. If I merge with 4, again I'll get 2 combination. Okay. So how many combination? 2 plus 2 plus 2. 2 plus 2 plus 2. What is that? 6. 6 combination, correct? How many line will be there? How many digit were there? 1, 2, 3, 4, 4 digit. So how many line will be there? 3 line, 3 into 2, 6 combination. So I can tell if n number of word I am taking, if the number is n, then this value will be 2 into n minus 1, correct? Is this correct? Value of n for these 3. Okay, I'll calculate this one also. Hold on. And how many will be there for this? We need to calculate that also. It will be 2 into n minus 1. That's, let's just check I have given correctly or not. Okay, yes. So this will be n, this will be 2 into n minus 1. Now, as I have left with this many word, 2 word is always different. So that's why I'm actually getting 2 condition. If the number were more, I may get more condition. Okay, so I can just write f of n minus 1. Okay, I'll get something called f of n minus 1. Okay, so if there are n word, n digit, then n minus 1, f of n minus 1 for rest. Okay, so this particular condition I will detect for last 3 digit. Okay, now let's calculate how many we'll get for this 1, 2, 3, 4. For this much I got f of n minus 1. Okay, because it's n minus 1 only. What I will get for this? How many will be there? So from 1, it will be 2, 3, 4. Now 1, 2, 3, 4. Now I have 1, 2, 3, 4. Correct. I have 1, 2, 3, 4. How many I got? 2, 3. How many digits were there? 1, 2, 3, 4. If 4 digits were there, then here it will generate 3 conditions. That means it will be only n minus 1. Correct. So n minus 1 plus f of n minus 1 will be my formula for fn. What is my assumption here? My assumption is this. I have assumed that f n minus 1 will always give me the value of these 3. This is my assumption. Okay. This is fn. What is my base case? If n is equal to 2, then always be 2 condition, 2 combination. Is it clear? Everyone, it is clear? Any more confusion you can ask before I move it to the programming. That one small condition I'm missing here. Function of n minus 1, it will be there, but there is n minus 1 into n minus 2 will be there. How many left actually? If I have 4, then n minus 1 will be there. 4. Okay, there is another calculation is also there. Okay, that we actually forgot to include. Nobody has questioned that one. I have done a mistake. That means none of them are actually now attentive here. No, this is not a Fibonacci series problem. So don't go with the deck. Deck is having a wrong answer there. It's not a Fibonacci series problem. I know it's already late. You guys are going with the shortcut phrase. It's called a shortcut phrase. That where we are trying to understand with our best patience possible, but try to be there. I have done a mistake here that nobody has questioned and told that everyone has understood. So again, that's a catch. So whatever I have in the deck, that's actually a wrong. It's not correct. Okay, so don't go with that. And I'm not telling you to get your attention. It's actually wrong. It's not a Fibonacci. I have already raised the concern to them. 1, 2, 3, 4. Okay. If n is equal to 4, so exactly after that, these 3 will be there. Okay. That is sure. Okay. That means n minus 1 will be there. Okay. But in each row, if you see my previous thing, in each row, there are some combination. In each line, there are some combination if you go there. So here also, if you think about this row, here 2 combination is possible, like 1, 2, and 3, 4. And here also 1, 2, 3, 4. Okay. So what is this formula? This is actually n minus 2. Your most n value is 4, right? And how many possible combination you can see in each row? That is 2. That means this is n minus 2. Okay. That means, so before it will actually be n minus 1 into n minus 2. Like n minus 1 into your function of n minus 2. N minus 2 is the number of combination possible in each. Okay. So this is the n minus 2 into n minus f into n minus 1. So the formula will be n minus 1 f of n minus 1 is equal to plus n minus 1 into f of n minus 2. So that will be your fn's formula. Okay. Now, anyone is having any confusion? If you are not having any confusion, we'll move back to our code. Okay, let's move to our code now. So let's just go with that. Base case, what is the base case? If length is 2, then combination is 2. That's the base case. Now function combination, I'll take n. Okay, 4 are there. Okay, this is not Fibonacci formula. Okay, confused on last formula. I'll go there. Okay, let me write down the program, then I'll go there in again on that formula. Okay, return. What will be my thing? I have done COMB n minus 1 plus COMB n minus 2, which is followed by n minus 1 into. Okay. Now base condition is if, I think base condition we can have 2 also. Yes, 1 and 2, all things are fine. N equals to 1 or n equals to 2. Same thing will happen actually. I can directly return n. Okay, so this is my formula. So this many things I am going to do here. Let's just run it once. Okay, Then I'll go to the first formula again. COMB. What is this? Suppose go for 3. It is going to return something else. Okay, console.log. If the combination is 3, it is going to return 4. That's my correct answer only. Okay. Now, confused on the formula, right? So if you have understood the program structure, what I've given depending on formula only, I have taken the program structure. So program you have understood, everyone. Then I'll go to the formula again. That will be the last of the class. Program you have understood, everyone. Any problem on program or in the formula? Any line, any problem in line? Understood the program. Okay, cool. Let's just delete all the things from here. Now let's just write. So let's just do the formula with 3 record only. Okay, we'll understood that one there. So what I told, this is my key element, and this one I want to get a pair. So this one can go along. If one is going along, then what are the possible combination can be? It can be 2 along, 3 along, or it can be 1 along and 2 and 3 group. If one is going separate. If one is going any of them, then there are possible 2 lines. One can go with 2, one can go with 3. So one is hello, there are many noise. One is going with 2 and one is going with 3. Got it? If one is going with 2, then what can happen? Then this 3 will be as single. If one is going with 3, then 2 will be single. Okay. So, and here what will be there? 1, 2, 3 will be there, 1 and 2. Okay. Now first understand the first formula, first part of the formula, which is this part. How many combination you can see here? 1, right? How many combination you can see here? 1, right? How many lines you can see? 2. So if the value is here n, right? N is equal to 3. How many lines are there? 2. That means line is equal to what? N minus 1. In each line, how many combination is possible? 1. That means what? N minus 2. Correct? So it is n minus 2 is possible. Now, if I give n minus 1 into f of n minus 2, then entire calculation will be there. Entire how many combination possible from these 2 line will be there, will be returned. N minus 1 time f n minus 2, because each line is f n minus 2, f n minus 2, and it is happening 2 times. That is a n minus 1 time. So n minus 1 time f n minus 2. Understood this formula? Hariharan, right? Still no. Okay, you can talk, Hariharan. You can talk.
Hello. Can you hear me?
Yes, tell me.
Yeah, that n minus 1 into f n minus 2. That is the part I'm getting confused.
Okay. How many combination possible in this line?
That's one combination possible.
One combination possible. How many combination possible in this line?
Yeah, that is also one.
1. What is this 1? Is it not, what is n? N is 3. 1 is not 3 minus 2.
Yes.
If 3 is equal to, if I take n, then what will be? N minus 2, right? Got it? N minus 2, how I'm getting n minus 2?
Yes.
So this is the n minus 2 combination only. correct? So this is my combination function, combination n minus 2, combination n minus 2, correct? N minus 2 times. Let's just consider with base case. If the value n minus 2's value is actually 2, then combination 2 will be what? Combination, if the combination is 2, then what will be that? 2, return will be 2. Similarly, if the combination is n minus 2, something will be written here, correct? What it will be returning? Number of combination possible. So this part you got or fn minus 2. That's what I'm writing, fn minus 2 only. This part is possible, complete.
Yes.
Understood?
Yeah, understood.
Okay. Now why n minus 1 into n minus 2, right?
Yes.
Now, how many lines will be possible here? If you have 3 elements, you have told that one will go along or one will go with others in the second situation, then what? One can go with 2, one can go with 3. That means 2 combination possible, right? 1 plus 1 here in this one, here in this one, 2 possible, right? If the number of element is n, then 2 means what? 3 minus 1 or n minus 1, correct?
Yes.
You can think about 4 element also, 1, 2, 3, 4. Then how many line you can draw? 1, 2, 3. That is also n minus 1. You can think about a 5. Suppose 5. How many line you can draw? Here, if you leave 1, 2, 3, 4, it is also n minus 1 matching, right? And each line will have what condition? F n minus 2 condition, correct?
Yes.
How many lines are there? N minus 1 times lines. So it is n minus 1 into f of n minus 2. Got it?
Yeah, got it.
That's the formula. That's our base formula, what I have exactly written here. N minus 1 into combination of n minus 2. Okay. Now,
What about the first n minus 1?
now first
Combination.
n minus 1. Okay. So if you think, if you're just considering, if you are just considering 1, 2, 3, I have given let's 4. If you are just, let's just go with 3 element only, easy to understand. If you are considering 1, 2, 3, I just consider these two. These two comes with n minus 1 into function of n minus 2, correct? But one can go along also, right? So that is another part. So these two I have calculated. Now I need to calculate this part, right? How many combination possible here? If one is going along, then one is possible 1, 2, 3. Another one is possible 1, 2, 3. How many possible combination? 2, right? Number of element what? 3. 3 minus 1 is what? 2. So n minus 1 is what? The possible combination from 1, correct?
Yes.
So I'll do what? Plus f n minus 1. This is my exact formula. You can try it with 4 element also. If it is a 4 element, in this row, you will get 3 conditions only. Just 4, 3, 4. If I'm going with this, so 1, 2, 3, 4 will be 1. 1, 2, 3, 4 will be 1. 1, 2, 3, 4 will be another. How many? 1, 2, 3. Number of element 4. So it is 3. So it is again n minus 1, right? F of n minus 1. So that's why the f of n minus 1 into fn minus 2 is going for rest. For this, I'm having fn minus 1. So that is the formula I have written here.
Yes, got it. Thanks.
Clear? Okay. I think we are done with the program. So you'll be getting some assignment also. So this program to construct recursive, it's all already there. There is one problem we left that you can try it out. For here also, you understand, try to go with base case and assumptions cases. So it will be better for you also. Okay. So this will be there. This is actually telling of the simple pattern. what is this? Calculate the binary string without any consecutive ones. Okay, try out this program, and there are some assignment also you will get. Okay, take a size of array, calculate the sum of array using recursion. This is very easy. Write a function to take a string and return the string palindrome. Okay, so these two are your class deck. It will be shared by the team. Okay, so you will not get this class deck. So some assignment and all things regarding this you will be getting. Check with the other team also. Check with your education team or something, because frankly this is my also first day, and I am only appointed to give a revision classes. Okay, so check with your contact or POC regarding the deck. Okay, any more question? Okay, if there is no question, then I believe we can wrap up the call. Okay, thanks Lanjan. Thank you everyone for staying here. Okay, bye, good night.